Good evening, everyone. Welcome to day 3 of the International Faculty Development Program on Futuristic Pathways in Technology and Computational Methodology. I'm Arun Kumar Ganeshan, your host for today. Over the past 2 days, we have witnessed simulating discussions and thought provoking sessions. And today, we continue this journey with a renowned speaker. To start today's session, I invite Mr. S. Merlin Javaraj, Assistant Professor, Department of Computer Science, to deliver the welcome address. The forum is yours.
Yes, sir. Good evening to all. It's my pleasure to welcome everyone to this third day of Faculty Development Program on Futuristic Pathways in Technology and Computational Methodologies, organized by Department of CS, Merimada College, Periyakulam. I would like to welcome our beloved Principal, Reverend Father Isaac PJ CMI, who is presiding this Faculty Development Program. Welcome you, Father. I would like to welcome Reverend Dr. Father Joshi Paramthottu CMI, our Vice Principal, and Reverend Father Bijoy CMI, our Financial Administrator, who has felicitated for this Faculty Development Program. Welcome you, Father. It's my privilege to welcome the Head of Computer Science Department and Convener of this FDP, Mrs. Narmada Devi, who has taken all initiative to conduct this FDP. Welcome you, ma'am. It's an honor to be graced by our chief guest, the center of attraction of today's FDP, Dr. Jackson Piri, Associate Professor, Department of Computing and Informatics, School of Natural Science, University of Zambia, awaiting for your innovative ideas to be presented. Welcome you, sir. I am glad to welcome the coordinators and organizing committee of this FDP. Welcome you all. It's my duty to welcome all the participants from various institutions, universities, and research centers who are participating with enthusiasm. Welcome you all. Thank you.
Thank you, sir, for the warm welcome. Now, it is my immense pride and honor to introduce our distinguished chief guest, Professor Jackson Piri, a name synonymous with academic brilliance and groundbreaking innovation. Professor Piri is currently an associate professor in the Department of Computer Science at the University of Zambia. With a remarkable teaching career spanning over 18 years, he is a beacon of excellence in the realm of software engineering and applied artificial intelligence. Professor Piri embarked on his academic journey with a bachelor's degree in computer science from the University of Zambia, followed by a master's degree in computer science from the University of Western Cape, South Africa. He then reached the pinnacle of academic achievement with a PhD in computer science from the prestigious Harbin Institute of Technology, China. An intellectual powerhouse, he has authored numerical, impactful research publications, with this work gaining recognition in esteemed international journals and conferences. His contributions have been acknowledged with accolades such as the Best Paper Awards at IEEE conferences. Beyond academia, Professor Piri has led and contributed to transformative research projects with global impacts, including initiatives funded by organizations such as the United Nations and the European Union. His work on artificial intelligence for development in Africa and ICT for food security epitomizes his commitment to using technology as a tool for societal advancement. Professor Piri's influence extends globally through his role as a peer reviewer for leading academic journals, supervisor to over 50 postgraduate students, and external examiner for universities across Africa and beyond. His expertise in digital identity management, agricultural informatics, and health informatics underscores his dedication to interdisciplinary research that addresses real-world challenges. Ladies and gentlemen, we are privileged to have with us today a visionary leader, a mentor to countless aspiring minds, and a true advocate for harnessing technology to improve lives. Please join me in extending a warm and heartfelt welcome to our chief guest, Professor Jackson Piri. Sir, the floor is yours.
Thank you very much. Thank you for the introduction. My name again is Jackson Piri. So I'll go ahead and share my presentation. and then I'll go ahead to do the presentation. My internet connectivity is not very good, so I'll keep my camera off, but I just thought maybe I should switch it on so that you can see the person who is speaking to you. And then I'll keep it off so that I can just conserve my bandwidth during the course of the presentation. Thank you. Okay, so once again, I would like to say thank you very much for the privilege to be invited to make the presentation. I appreciate so much. I just wanted confirmation if you can see my presentation.
Yes, sir, it is visible.
Okay, thank you. Okay, so I am going to make this presentation, and the title that I decided to give it was Embracing Industry 4.0, Navigating the Challenges and Seizing the Opportunities. I want to look at this from the perspective of us in Africa, and also how we are trying to make best use of these emerging technologies to address the issue of food security, which is the biggest problem in developing countries, Africa being one of them. So what I've decided to do is to divide this presentation in 3 parts. So I'll just do the introduction on the new digital era, or just Industry 4.0, which most of us are familiar with. It's not very technical, so I've just kept it raw so that we were able to move at the same place. And then I'll talk a little about the issue about food security, but digital agriculture, what we are doing here now. These technologies to try and address some of the problems that we have here. So only 3 parts. The first part is to look at just the introductory part, the digital era, and then I will look at the introduction in terms of agriculture, and then some examples. Then I'll open it up, then we can discuss. So I'll start with the basic definition of Industry 4.0. Again, we are familiar with this one. The bottom line is about automation, and we know that actually the UN, they've also been talking about this. It's a central figure. So why we talk about this so much is because it's affecting the skill set, the job market. It's also affecting our lifelong learning activities. So these 2 parts, there are many other areas, but these, I think, they are critical for us, especially in academia, how these are affecting us. I think in the previous session, somebody was talking about natural language processing, ChatGPT, and how that is affecting us, which is part of these technologies that are under Industry 4.0. So in 2023, the World Economic Forum, under the same Industry 4.0, issued this document where they looked at the top 10 technologies that will affect us maybe in the next 5 years. So I've just put a link here. I think the slides will be shared. You can go there and then read for yourself. Also, in the same year, 2023, they issued again another document where they've outlined the job market, how it looks like, the jobs that will more or less like diminish or disappear, and the new jobs that are coming on the market, largely because of these emerging technologies falling under Industry 4.0. Again, you can look up, I've put a link here to look at this space and how it is, this will affect us. It will affect the developed countries different from developing countries like us in Africa and maybe part of India. India is halfway, I think, more developed than the other, but those areas which are more or less like Africa, I think will be affected in the same way. And so in terms of the education, I think we will need to realign in terms of the subject areas and the skill set on how we're going to deliver on this one. This is just a small picture to just show the stages. Industry 1.0, the steam in where we started from with the steam engine, largely I think for pumping water and driving machinery, and then 20th century, gasoline vehicles, electricity was invented, and a few others. And then Industry 3.0, the IT, the computing era after Second World War. I think this is where we were. And then Industry 4.0 estimated to have started from 2018, 2016 until wherever we will be going. I think we're in that era for now. So this is just a depiction here. You will find this web page under the United Nations Industrial Development Organization, where they've talked about us entering into the new era, just talking about emerging technologies in principle and how this is going to affect us. I think this is just the introduction. My interest starts from here. How does the digital space look like in the world? So there are these organizations that I've put here, about 12. They help to collect data and inform us about what is going on and what the space looks like, where we are operating on around the world. So some basic statistics. There are about 5 billion internet users in the world today. And about 500,000 new users are added each day. We're about, of course, the other statistics is about 5 billion unique mobile phones users in the world today. I think those that are using data from the GSM. So the actual pictorial view looks something like this. Again, you can pick up this information. I've included the source for you. As of April 2024, the world population was at about 8.1 billion. And about 5.6 billion of this population had unique devices. About 5.4 of this population was on the internet. And about 5 billion, which is about 62%, 63%, at least we are using some form of social media. So this is how the digital space looks like. In terms of the statistics, percentage-wise, where I come from in Africa, especially the southern part where I belong to, we only contribute 1% of the actual usage in terms of the internet. So as we are still growing, the job market here is still open. The research area is still very open in this space, and I think there is potential here. Europe is about, Western Europe is about 3.4. The US is about 6.8, but you can check Asia where you belong. I think where India is, it's about 20%. And together with maybe China, Korea, and Japan, together with Southern Asia, you get about 50% of the usage of the share of the internet. So I think here, this is where there is a lot of activity. The rest, I think, we share. In Africa, I think all of us, I don't think we reach even 15%. So this is what it looks like in terms of the global sphere. In terms of the main reason for using the internet, I think these are the ones that are here, but the major one is that we are all looking for information and we want to also stay in touch with colleagues and friends. But the major one is this one. So for the purpose of us who are in the education sector, we can see that actually only for those in the age band between 16 and 24, only 52% of them are utilizing the internet for education purposes, but the majority, 60%, is socializing family and friends. Between 25 and 34, it's right at the bottom, only 38%. The majority, of course, is finding information. This group, it's about 48, 50%, and the rest of the statistics go on. So here, again, just the usage of the internet, what do you use the internet for, and a few other parameters. So for social media, this is what they are using it for. And yeah, this is the status quo. For now, this was just the preliminaries, and then now I go to the second stage where I want just to talk about the drivers. So for the Industry 4.0, what are some of the tools and technologies that are available? So I listed them here, and some of them, I think we looked at them yesterday. So these are amongst the technologies that are within the emerging technologies that form the Industry 4.0. But key, I think, issues to do with gene editing, robotics, self-driving car, cryptocurrency, quantum computing, Human 2.0, Education 4.0, and a few others. These are some of the components, I think, that fall within the this space of Industry 4.0. So with this now, how can we use this for us in developing countries to help and deal with the issue of food security? Because us who work with in this space, computer science or computing, we have to find a way of applying our element to the various areas. So I decided to pick agriculture, because this is one of the big problems here in Africa. Food security is always an issue, and we are always struggling with it, especially in the wake of climate change and these global changes. So we need to find a way to look for methods, to look for ways in which we can deal with this food security, but taking note that actually we have limited resources. So this is why I decided to pick up this one, so that I can just give an example, some examples of what we are doing this side from the research point of view, and how we are integrating these. So the world population is estimated to reach 9.6 billion by 2050. But as I showed you on the other slides, we are already at 8. So I suspect maybe even as early as 2030, we might be reaching around 9 billion. And so the challenge is food crisis and food security. And so new methods and better methods of managing food, growing food, and keeping it or taking it to the market needs to be done. And so with these emerging technologies, these tools that are available here in Africa, we are trying to take advantage of these and see how best we can apply them. So some of the areas where these emerging technologies can be applied, or where they are being applied here in Africa, my country to be specific, issues to do with food traceability, where the food that we are eating, where is it coming from? Food security, do we have adequate or enough food? And then farm automation, Of course, we don't have the resources, but to what extent can we do this automation in order to address some of the issues that we are facing? We keep a lot of animals here, like cattle, sheep, and goats for the small-scale farmers. How can we improve that process and address issues to do with the disease and the pesticide and a few other things? And then we translate this information on a geospatial mapping, mapping some land spatials and a few other parameters. The FAO has been sponsoring or supporting most of these activities. Again, I've put something for you here and the link below. You can look at some of this content. There are these apps that have been developed, which are being used to address most of these challenges that we are facing here. Issues to do with the animal health, issues to do with crop disease, and a few other parameters. And so here I've just indicated that actually digital technology in agriculture is a key thing. And for us, I think here in Africa or developing countries, we look at this as one of the enablers or something that can help us to try and deal with this food crisis or hunger that we are facing. And so we strongly feel that actually Industry 4.0 or emerging technologies can help us actually to reduce the cost of access to technology and also improve our capacity in the value chain in terms of the food supply. Specifically, most of the technologies within these emerging technologies like Internet of Things, mobile technologies, GIS, remote sensing, artificial intelligence, distributed computing, these we can easily apply them. We build small applications, apply them and allow ourselves to deal with some of the challenges like supply chain, land parcel, which place, which farm place belongs to which one, what are the demarcations for that land mass. We have a lot of land in Africa, but also there is also a lot of infighting about some land space. Who does it belong to? What are the beacons, the marks, the demarcations for that piece of land? So GIS and a few others here, they play a very important role. So for the introductory part, I think this is what I had. Now, I just want to share some 3 examples of some things that we've been doing where we applied them. There are many others that we are doing, but specifically for the agriculture sector, where we've done some research, and this research has gone back to the community. I have 3 examples that I thought maybe we could share. The information above, most of it, you have it, but I thought maybe this would be, it would help you to understand us on the other side and also maybe appreciate how the challenges that we are going through and what we are doing in terms of embracing these emerging technologies to do research. So I have 3 examples. I'll go through each one of them. The first one is the problem of the 4 armyworm. I'll give the details. Here we were funded by FAO under the United Nations. The second one, we were funded by the EU, but we're trying to look at the problem of locusts. The last one, which was actually the first one, here we're funded by the government of Zambia and the government of South Africa. So the 2 governments funded this project to look at supply chain and storage for the food here in Africa, Southern Africa. So I will give the details. So the first one was the research. This research we did it in 2018. We started from 2018. We were given some money by the Food and Agriculture Organization. So the Department of Computer Science, we were working with our friends from the Department of Biological Sciences, who are experts in entomology. And so our challenge was to build an early warning system model that uses Internet of Things, cloud computing, and then we integrated artificial intelligence inside machine learning, to be more specific. So this is how we worked on a solution. So I'll explain what the problem was. So our friends in biological sciences, they were having a problem with this pest. For armyworm, the scientific name is here. It eats maize, the maize grain, corn. It eats a lot of corn. So you can see here, this is damaged one. And this is how the moth looks like. So they have this trap that was given to them, which they have with this pheromone here, which is a hormone. And this thing, they used to take it in the field with this thing. So this insect will be attracted here and it will be trapped to fall in here. Every day they would go and open and count. The problem that they had is the farmers were not counting because they wanted some money from whoever brought these things. That's how they would now get engaged. Or they were just lazy. So it was difficult to get the real data on the ground. So we came in to modify this part and automate this part. So we did three things. We inserted cameras here and then attached microcontrollers here and then powered this thing using solar so that it's off the grid. And then attach GSM so that we can tap the data from here and take it to the cloud. So this is one of the publications from a journal in Australia. So this was part of the output of that work, which we did together with our colleagues from biological sciences. I've added the link again here. It's open access. You can download this paper and then you can read the details on part of the output of what we are working on. The same work, this is the other paper. We had two students who were working on with us here. So this one, it appeared on this journal. Again, it's open access. You can download this paper. It's available. You can read about the details. I've put a link also here direct. You can read about the works that we did here. We had colleagues from Department of Plant Science in the School of Agriculture Sciences, Biological Sciences, and ourselves from Computer Science. So we worked together to solve this problem. So like I said, our country received 2,200 of these. And so they were not getting the solution. So they gave us money at the university to try and address this problem. So what we did is we built something. I have a diagram here. We had the solar panel, which is here. We also had to collect the environmental variables. So we had to collect the wind direction and wind speed. And also we are collecting temperature and humidity. So from the solar panel to the solar control, to the charge controller and the battery here. Then from the charge controller, we got our 5 volts to power the Raspberry Pi, the camera, and the Arduino. The modem also had to be powered from here. So the sensors, temperature and humidity had to sit on were sitting on these components here. This is the actual setup, which was boxed. I'll show you somewhere. So this is the actual setup of the components inside. This is the tin that we modified. That thing that I showed you is the one that is here. So this is the actual implementation. Solar panel here and the battery here and our components inside here, and then the modified part here. We had to add some light so that we can attract the insects in the night. So this is the component which was modified with a camera. This is the camera actually that is here, that we had attached inside so that we can take the images of the insects. We're interested in the moth itself. So it's these images. We already had some samples, so we had to create the training data set from the samples that we had. And then we annotated the most of these so that we can get a slightly large sample space. So this is what we had, and then we corrected these and a few other things. Then we built the model using convolutional neural networks. And this is what it looks like. We trained and then we built an application behind it. And then built the backend, a web application here. And then these are the parameters that we are getting: temperature, humidity, and then these traps. We had to build a spatial map where we were keeping this direction. So these are some of the statistics that we had. So we had to build this and just put some beacons where we had those traps. Each one of these. So these, where we set up this, we picked also the GPS location, and then we had them like this set up on these. And then each one of them had information. You just click on the beacon and then to display the information for you. Then we had to color code our country. So depending on, we set the threshold in terms of the catch. So the trap, this trap was able to catch the moth and then identify them. If it's the correct one, then it was giving us a count for that particular station. And then if the count exceeds a certain number within a given period, it will start color coding our map here. So most affected it will show, less affected, and so this was more or less like an early warning system. Basically, I think this is how we were solving this problem, and this is how we solved it. We just automated the whole process, removed the farmer. The system was just able to do everything by itself. That is our first example that I can give. Our second case that I can give that we are working on is the problem of locusts. These, they destroy crops. And so we had this challenge in our country. And so we had applied for some funding, and it came from CIDA and the rest of our cooperating partners here. This is just a picture when we were in the field, in the plane, where we went to catch the actual locusts. This is the professor for entomology. And these are the people we hired to help us to catch the insects, because we couldn't find them ourselves. So we wanted to catch as many as possible so that we can use them to create a training data set, annotate and then create a data set. So we had to collect as many as possible. You can see the bottles behind here. We're in the field. So we collected these, built a model, and this just as an example of how we were doing the recognition. So we had to go and set a code to start identifying some of these. Immediately they start picking up. These are just some of the examples of part of the output that we were working on. For this work, there were 2 publications. Both they went into Springer for some conferences in Europe, 2 of them. This is the conference. So we did 2 papers from this work. So this is an example of the African migratory locust and the things that we worked on. The last example that I wanted to give is the food supply chain. We as a country, we had a problem. When the small scale farmer grows the food, they sell to the government. But the government was losing money because part of the food, but part of the grain was being stolen. Also, storage was a challenge because part of the grain was going bad. The other problem was also to deal with the farmers, where are they coming from and how much is their space where they grow things. After the farmer sells the products to the government, how do you pay the farmer? So in 2017, 2018, we did some work on these components. There were 1, 2, 3, 4, 5. So we built these 5 modules for the agro portal for the country to try and address these issues. Basically, I think this is what the architecture looked like. We had the ministry, the division of the different government officials who work on the same thing and their arrangement. This is just a small dashboard on how we are onboarding the farmers on the system. And this is how we built a system to map the land, a small piece of land where the farmer was growing his food. When they grow the food, they'll take it to the warehouse. Then we had to track now the movement of the products and a few other things. So again, you click here, it will just give you these details. This is the publication that came up from, again, it's an open access journal. I think this should be in Australia, but I think it's yet to be confirmed. But you can, again, get this paper, it's available. You just look at how we integrated QR code and a few other information in order to start tracking the bugs and a few other things. This is another paper that was done just to deal with the issues to do with the grain tracking model and issues to do with e-perimeter in order to address the issue of theft of government grain. So we had to deal with IoT and a few other areas. So this is a publication. Again, you can download it. It's available here. Basically, I think that's the presentation that I had for you today. Just the 3 examples of what we are working on and the preliminaries. So I will open up this for the discussion. You can now ask me some questions. My presentation, I will end here for now. Thank you.
Thank you so much, Dr. Firi, for your engaging and informative session. Participants, we now open the floor for your questions. Please share them via chat or raise your virtual hand. Dear participants, if you have any queries, please turn on your microphone and ask. Now I invite my fellow coordinator, Mrs. B. Shakti Maheswari, to speak few words.
Good evening to all. Respected Dr. Firisa, I would like to extend my heartfelt gratitude to you for accommodating my request to deliver a session at the FDP despite your busy schedule. Leena ma'am spoke highly of you, mentioning that you are one of the busiest professionals. Yet you graciously accepted my invitation without any prior introduction. Your presentation was both insightful and impactful, leaving a lasting impression on all attendees. Thank you once again for your valuable time and contribution to the program. Thank you, sir.
Thank you very much. Thank you.
Arun, sir. Arun, sir.
Thank you. I got the message. Thank you very much.
Fill it as soon as possible. Dear participants, attendance link will be available only for a limited time, so please fill it at your earliest convenience. And I have posted the attendance link in both Google Meet and YouTube chat box. Please fill it ASAP.